All right, so we still haven't found our Goldilocks, so now it's time to move on to our FCC structure. So FCC is face-centered cubic. Let's go ahead and erase all this good stuff. FCC has atoms on the face, as the name implies. So you have here, 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 and then on each of the 6 faces. So now that we have, again, we still have an eighth, an eighth, an eighth, an eighth, an eighth, and if you can imagine the next cell on top here, we are going to have atoms like this. So that face atom is going to be shared by 2. So each of the face atoms contributes a half. So 1/2 plus 1/2 is 1, 1/2 plus 1/2 is 2, 1/2 plus 1/2 is 3. So we're going to have 4 atoms here. Nearest neighbor distance is the same. It's a little bit hard to visualize the number of nearest neighbors, but you can kind of see that across here, these atoms are touching. So you're going to have 12 numbers of nearest neighbors. And you can kind of visualize that here because you're going to touch 1, 2, basically 3 here, and then you can kind of touch the ones on the bottom as well. So kind of that 4-fold symmetry that pops up. So that's what we're going to anticipate and actually observe here. Next nearest neighbor distance, that will also be A. So if this is their nearest neighbor here, and then you could have a triangle that shows up like this, so where this is 4R again. This is A, this is A. So our A, our last parameter is going to be 2R root 2. There you go. Atomic packing factor, or actually close pack directions. So we see a close pack direction right here, and that's going to be the family of 1, 1, 0 directions. Then finally, atomic packing factor. Well, we have our A for FCC. AFCC equals 2 times R times square root of 2. And we know we have 4 atoms. So again, we can just copy and paste here for AFCC. And what do you know it? There's the one. So that is a close pack structure. FCC is indeed a close pack structure. And we can, I mean, again, it makes sense when we look at many FCC structures are much more ductile. Much more ductile than other materials. But we have one row remaining. Close packed planes. So to do that, we have to actually go through a journey of looking at planar density. So planar density is effectively the ratio of the area, and actually a close packed plane will have this following planar density, but we'll leave that for the next video. So I'll see you all in the next one. Bye.